Good evening, guys. Listen. So we have completed till 7.3 yesterday, right? We discussed a few problems also. Tell me, is there any doubt that you have till now? So from whatever has been discussed, do you have any doubts? Is there any problem that you want me to solve and show? Am I audible in the first place?
Yes, sir, you're audible.
Okay. So can I take it as no doubts?
Yes, sir.
Okay. So the next topic that we need to see is combinations. We have completed permutations. Now we're seeing combinations, right? So combinations basically means selection, right? So let's take an example. Let us assume that there is a group of 3 lawn tennis players X, Y, Z, and a team consisting of 2 players is to be formed. That is our job. So there are already 3 players that are available, and from those 3 players, we are expected to form a team consisting of 2 players. In how many ways can this be done? So is a team of X and Y different from the team of Y and X? Here, the order is not important. Why? In the case of arrangement, that is the case of permutation, when you're saying you are arranging something, you need to place them in order. Whereas when you're selecting something, what is going to happen? You're not going to place them in order. Rather, the order is not important at all. So can I say something like this? Right. Listen to this carefully. You have 3 players. Listen, I'm giving you a different perspective. From those 3 players, you need to pick 2 players, and let's say you're arranging them. Okay, if I say something as 3P2, then can I say 3P2 is nothing but the meaning of 3P2 is selection and means into arrangement. Can I say it like this, guys? Right. So 3P2, can I write it as in the place of selection, out of the 3 players available, you're choosing 2 players into, you're arranging those 2 players in 2 factorial ways. So can I say 3C2 is nothing but 3P2 divided by 2 factorial? Sorry, guys, able to understand? So basically, selection is nothing but the number of ways you select something divided with what? Divided with the number of ways you are going to arrange it, because you are repeating the same process multiple times. Okay. So this is what can be generalized as something like this. NCR is equal to NPR divided by R factorial. Means you have n objects in your hand, and from those n objects you are supposed to choose R objects. Then you write NCR is equal to NPR divided by n factorial. So this is the formula, guys. So we already know the formula for NPR. It is n factorial divided by n minus R factorial, the whole divided by R factorial. So it becomes n factorial by n minus R factorial into R factorial. Is this clear? Okay. So NPR is equal to NCR into R factorial. This is what happens. Now, there is another theorem that you need to know. NC0 is equal to 1. Why is it so? Because it is n factorial divided by n minus 0 factorial into 0 factorial. So it is n factorial by n factorial into 0 factorial. Cancel these two. 1 divided by 0 factorial 1 divided by 1 is 1. Similarly, you need to know that NCR is equal to NC n minus R, because NCR is n factorial by n minus R factorial into R factorial. What about NC n minus R? It is n by n factorial divided by n minus of n minus R factorial into n minus R factorial. That is n factorial divided by R factorial into n minus R factorial. So this and this are the same. So there is a very important theorem. When binomial theorem was there, this is the most applied formula to solve many of the problems. But yeah, it is worthy to know this. NC n minus R is the same as NCR. Similarly, NCA is equal to NCB happens 2 times. NCA is equal to NCB when A is equal to B or A plus B is equal to N. That is, 10CA will be equal to 10CB either if A is equal to B or if A plus B is equal to 10. Okay. And the last theorem that you're supposed to know is, so guys, I'm going a little faster because I'm assuming you already know all these things. Okay. So theorem number 6 that we need to understand is NCR plus NCR minus 1 is equal to N plus 1 CR. So NCR plus NCR minus 1 is equal to N plus 1 times CR. Okay, this is the last theorem. So what you can do, you take the LHS and try to solve it, you will get the RHS, not a big deal. Okay, so let's do some example problems that are based on this. If NC9 is equal to NC8, then find NC17. So if NC9 is equal to NC8, then what is the value of N? Even without solving, you can say using theorem number 5. NCA is equal to NCB if
N
A
plus
plus
1.
B is equal to N. So 9 plus 8, that is 17. NCA is equal to NCB if A plus B is equal to N. No. That's what this theorem says. NCA is equal to NCB if A plus B is equal to N. So N is 17.
Understood, sir.
So what is NC17? 17C17 is 1. 17C17 is 1. 18th example. There is a committee of 3 persons is to be constituted from a group of 2 men and 3 women. In how many ways can this be done? So when generally when they say constituted means it is to be formed. How many of these committees would consist of 1 man and 2 women? So there are 3 people available. So sorry, the requirement is 3 people. But how many people are available? You have 2 men and 3 women. So totally 5 members are available. So out of 5, you need to choose a committee of 3 members. How many ways can you do it? From the 5, you can choose 3. See, C doesn't mean choose, okay? I'm just using it for the notation. So it is 5C3. So it is 5 factorial divided by 3 factorial into 2 factorial. So 5 into 4 divided by 2, it is going to be 10. So you can form 10 such committees consisting of 3 people from the available 5 members. How many of these committees would consist of 1 man and 2 women? So out of the 2 men available, you need to choose 1 man, and out of the 3 women available, how many are you supposed to choose now? You need to choose 2. So that 1 man plus 2 women put together will give you a 3-member committee. So 2C1 is 2 into 3C2 is 3 factorial by 2 factorial, which is going to be 3. So it is 6. So you can do it in 6 ways. Clear?
Yes, sir.
Correct. So, what are the number of ways of choosing 4 cards from a pack of 52 playing cards? So, choosing means combination. In how many of these 4 cards are of the same suit? 4 cards belong to 4 different suits, are face cards, 2 are red cards and 2 are black cards. Cards are of the same color. First one, from a deck of 52 cards, you need to choose 4 cards. Then 4 cards are supposed to be of the same suit. So first of all, what are the number of ways of choosing 4 cards from a pack of 52 cards? So it is 52C4, right? So solving part, I'm leaving it to you. So first one, you need to choose 4 cards which are of the same suit.
13C.
So you have 13C4. Second, 4 cards belong to 4 different suits. So from the available 13 cards from one of the suits, you need to choose one. And from the available 13, you need to choose one. And from the next available one, from the next available, you need to choose one. So 13C1 is 13. So answer will be 13 power 4. Wait, I made a mistake. 4 cards are of the same suit means you can choose 4 from diamond, or you can choose 4 from club, or you can choose 4 from spade, or you can choose 4 from heart. So we stopped it with 13C4. That was wrong. So 13C4 from the diamond, or 13C4 from the club, or from the spade, or from the heart. So you need to choose 4 cards which are face cards. So how many face cards are there, guys?
12.
So Jack, King, Queen, right? J, K, Q. So each suit into 4, that is 12, correct. So out of 12, you need to choose 4. So 12C4. Is there anyone having problem with cards? Everyone is clear? Okay. So 2 are red cards and 2 are and means multiplication. 2 are red cards and 2 are black cards. So how many red cards are available? 26. From the 26, you need to choose 2 red cards. And from the remaining 26, you need to choose 2 more black cards. Right. Fifth one, cards are of the same color. Means out of the 26 available red cards, you can choose all the 4 from there, or from the available 26 black cards, you can choose all the 4 from there. So 26C4 plus 26C4. Guys, this is a good problem. There is a possibility of you getting it. Any doubt in this? I'm assuming it is clear.
Yes, sir.
Any doubt?
No doubt, sir.
Okay. So the first one, NC8 is equal to NC2. So what is NC2? N is equal to how much? Tell me.
10,
By
sir.
now you should have calculated 10. So they're asking what is 10C2. 10C2 is the same as 10C8. NCR is equal to NCN minus R. So 10 factorial by 8 factorial into 2 factorial. So 10 into 9 divided by 2, it goes 5 times. It is 45. Second one, 2 minutes time, solve it and tell me, make it fast. 2nc3 is to nc3. So 2n factorial by factorial equal to n factorial by n minus 3 factorial into 3 factorial. 3 factorial and 3 factorial will gone. So 2n factorial is equal to 12 is to 1 now. Divided by is equal to 12 divided by 1. So 2n factorial I can write as 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial divided by 2n minus 3 factorial, the whole divided by n into n minus 1 into n minus 2 into n minus 3 divided by n minus 3, sorry, n minus 3 factorial, and this will get cancelled, is equal to 12 divided by 1. n minus 1 will cancel this 2 times. So this and this will get cancelled. So 4n minus 2 divided by n minus 2 is equal to 12 divided by 1. Correct? 8 and 20. Wait. 8n is equal to, how can I get n as an odd, as a fractional value? Is there any mistake here, guys? 2n,
Sir, actually, no, sir.
2n minus 1. No mistake, no? I left a 2 here. So it is 8n minus 4 divided by, or I can say that 2 will cancel this 12 on the other side 6 times. So this will become 6 by 1. 6 by 1, and this side I will get 4n minus 2 divided by n minus 2. So 4n minus 2 is equal to 6n minus 12. So 2n will be equal to 10, n will be equal to 5. So n is 5 in this case. Next one I'm leaving it to you. You guys can try it. Third one, what is the answer? Wait, we do it in this. How many chords can be drawn through 21 points on a circle? So you have 21 points. To draw a chord, you need to choose any two. So 21C2 is the answer. How many ways can a team of 3 boys and 3 girls be selected from 5 boys and 5 girls? So from the 5 boys, you need to choose 3 girls into, from the 4 girls, you need to choose 3 girls. So 5C3 into 4C3 will give you the answer. Find the number of ways of selecting 9 balls from 6 red balls, 5 white balls, and 5 blue balls. The selection consists of 3 balls of each color. Find the number of ways of selecting 9 balls. So you need to select 9 balls from 6 red balls, 5 white balls, and 5 blue balls if each selection consists of 3 balls of each color. So 6C3 into 5C3 into 5C3. Did you understand why I wrote 6C3 into 5C3 into 5C3? So you need to look at the numbers at the bottom. When you add them, you should get the required number of objects. So 3 plus 3 plus 3 is going to give you a. So determine the number of 5 card combinations out of a deck of 52 cards. If there is exactly 1 ace in each combination.
Sir?
Tell me.
Sir, can you explain before some?
See, did you read the question? Find the number of ways of selecting. Selecting means combination. How many objects should you select? You need 9 objects, but how many objects are available? objects. They have
Sir, your voice is breaking.
Yes, sir. Your voice is breaking.
Is it 1 minute? So what I'm trying to say is, from the 6 available red balls, you need to choose 3, because that is what they have imposed here. 3 balls of each color. Correct? So 63 into, you have 5 white balls. From 5 you need to choose 3. 5C3 into the remaining 5 you need to choose 3. That is another 5C3.
Okay,
So
sir, got it.
So let's try the next one. Determine the number of 5 card combinations. They themselves told combinations. Out of a deck of 52 cards, if there is exactly 1 ace in each combination. So you need to determine the number of 5 card combinations out of a deck of 52 cards. So out of the 52 cards, you need to choose 5 cards. But in those 5 cards, you need to ensure that there is exactly 1 ace in each combination. So how can you do that? So how can you do that, guys?
Sir, 48 C. 1 second, sir. 48 C4 multiplied by 4C1.
How is it? Is it only 4C? 4C1, correct. I'm not getting a call.
Sir, it is 48C4 into 4C1.
1 minute, 1 minute. I'm just getting a call. I'll finish. What were you saying? Yeah.
Sir, it is 48C4 into
Exactly one ace means there are 4 ace available. From the 4 ace, you need to choose 1, and the remaining should be. So how many cards are remaining? You have 48 cards. From those 48 cards, you need to choose the remaining 4. So as I told you, the logic is this 1 plus 4 should be equal to the number of cards that you need to choose. In how many ways can one select a cricket team of 11 from 17 players in which 5 players can bowl, if each cricket team of 11 must include exactly 4 bowlers? So you should always satisfy the condition first. Okay. You should always satisfy the condition. So 5 players can bowl and you need 11 players from the available 17 players. So exactly you need only 4 bowlers. So from the 5 available bowlers, you first choose 4 into. How many players are available in your hand? Now, how many players are available? Out of the
12.
17, you have 12. From those 12, you need to choose the remaining 7. So 5C4 into 12C7 will give you the answer. I hope everyone is clear with this, right? So as I told you, the technique to solve these kind of problems is first impose the condition and then think of the alternative. Now, you have a bag which contains 5 black, 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. So out of the 5 available black balls, you need to choose 2, and from the available 6 balls, you need to choose 3. 5C2 into. Right? I hope it is clear, right?
Yes, sir.
Yes, sir.
It's the last problem from this exercise. In how many ways can a student choose a selection? Choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student. Yeah, tell me. So first I told you, right, you need to choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory. So the 2 specific courses which are compulsory can be chosen in 2 ways. That is in one way. 2C2 is one actually. Into now, how many are the remaining courses that are available?
7C.
7C? 7C?
3, sir.
Correct. So 2, the remaining, so 5 courses, 2 plus 3 will give you a. I think these problems are simple, right? But the challenge will come when you're facing miscellaneous problems. So let me solve few more miscellaneous problems, then we can wind up. So let's discuss how many words with or without meanings each of 3 vowels and 2 consonants can be formed from the letters involute. Hmm? So what are the vowels available? I, O, U, E. And consonants, how many are there? N, V, L, T. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 or more. So tell me how to solve this.
So 3 vowels can be chosen in 4C 3 ways.
Into 4C.
Sorry. 1 minute. But you are there is calling me. Sorry, you were saying something. So in how many words with or without meaning each of 3 vowels and 2 consonants can be formed? The formed means arranged. Right? Words have to be, letters have to be arranged. So how to do this? So first you need to choose and then arrange them, right? So how many words, how many letters are we supposed to choose first? How many letters are required? 3 vowels and 2 consonants. We need only a 5-lettered word, right? So how many vowels are available? 4 are available. From that you will choose 3. And how many consonants are available? 4, from which you will choose 2. So 4C3 into 4C2 into, you have chosen 5 letters and those 5 letters you will arrange them among themselves in 5 factorial ways. Is that right?
Yes, sir.
Right? Yeah. Next.
So formed means like we are choosing first and then arranging it.
See, that is what permutation only, right? It is permutation only. But the thing is, I would have directly written permutation had it been like we are making use of all the letters, but they imposed a condition. That is the reason I went with the process of choosing and then arranging. So this is the process of choosing, and this is the process of arranging. Clear?
Fine.
So a group consists of 4 girls and 7 boys. Okay. In how many ways can a team of 5 members be selected? Selected means combination. If the team has no girl. So a group consists of 4 girls and 7 boys. So totally 11 members are available. In how many ways can a team of 5 members be chosen so that first the team has no girl. So team has no girl means from the available 7 boys, you need to choose all the 5. That is the first one. Second, at least 1 boy and 1 girl. At least means this is where the combination of or comes into picture. This is a slightly bigger thing. This at least is a very dangerous word. So at least 1 boy and 1 girl. So what combinations are possible? So if you start with 1 boy, you will have 4 girls. You have 2 boys, you will have 3 girls. You have 3 boys, you will have 2 girls. You have 4 boys, you will have 1 girl. Is that, can I write 5 boys and 0 girls? Can I write
No,
5
sir.
boys and 0? No, because they told at least 1 boy and 1 girl. So 1 boy and 4 girls means how much? 7C1 into 4
C4.
4C4 or 7C2 into 4C3 or 7C3 into 4C2 or 7C4 into 4C1. Clear? Right? This is a good problem actually. Okay. Find the number of words with or without meaning which can be made using all the letters of the word again. If the letters are written as a dictionary, what will be the 50th word? So if the letters are written according to dictionary, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5-lettered word. Right, in this 5-lettered word, A appears twice. So A will come here and A will come here. Accepted?
Yes, sir.
After this, what is the letter that is supposed to come here?
G,
So
sir.
first of all, with the word again, with the letters of the word again, how many words can you form? You can form 5 factorial divided
5
by 2
factorial
factorial.
upon 2 factorial.
So it is 60. See, for example, 40, right? The question would have been wrong. Why? Because you're already able to form only 40 words, but they're asking you the 50th word. So first we need to make a check of this. So A is there. Then what is that you can put here?
G, sir.
So G. So after AAG, what is the next word that you will put here?
I.
I only here. And then N. Right. So A. If I start the letter with A, the second letter is also A. Okay. Okay. I should actually, if I start writing like this,
Sir,
then I have
we
to
can
write.
count the number of ways, sir.
Yeah. Then I have to write the whole dictionary. So if you start with A, then 4 letters are available. So those 4
No, sir,
letters
like
among
this only I
themselves.
meant.
Yeah. the 4 letters can be arranged among themselves in 4 factorial ways. So 4 factorial is 24. But still we are yet to reach the 50th. So now if A is over, what will be the next letter you will go for in the dictionary? So you will start with G. Right. So when you start with G, you have 4 more letters. So you can write them in 4 factorial, but you need to divide it with 2 factorial. Why? Because
A is repeating.
in those letters, yeah, A is repeated twice. So 4 factorial by 2 factorial is going to give us how much? 12. So 24 plus 12 is 36. So after this, I'll start with I. 4 letter. Again, you have 12 more. 4 factorial by 2 factorial. That is 12. So 36 plus 12 is 48. So after I need to start the letters with N. So after N, I'll put an A here and A here. I will put I here and G here. After this, I'll put N, A, G and I. Or GHI. So this will be G and this will be I and this will become I and this will become G. So this is the 50th word and this is the 49th word. Did you guys understand how I arrived at the 49th word? Because 24 plus 12 is 36, 36 plus 12 is 48. So 12 letters are all 12 words are already exhausted with I, starting with I. So if that is over, then I need to go for the next letter, that is N. If I start with N, obviously I'll put A and A, then I'll go to the next letter, that is G, then I. Then again, next word will be in such a way, NA is going to be common. This has to be swapped. We have to swap it from the right hand side. Correct? I hope it's clear, right? So how many numbers greater than 1, 10, 100, 1000, 10,000, lakh, 10 lakh? So 1 million can be formed by using the digits 1, 2, 0, 2, 4, 2, 4. So how to solve this? So it's how many numbers greater than this? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. By the digits 1, 2, 0. So 2, 3, 4, 5, 6. So we have 7 numbers already in our hand. So since the number has to be greater than 10 lakh, what are all the possible numbers? What are all the numbers possible in this place? So you can put 1, 2 or 4. Correct? So if 1 is put here, okay, then you have 6 blank spaces. In those 6 blank spaces, what can you do? You can arrange the numbers in 6 factorial and divide it with 1, 2, 6 factorial by 3 factorial into 2 factorial. Why did I write that?
2 is repeating 3 and
yeah, 2 is repeating 3 times, 4 is repeating 2 times. So you will get a number. Okay. Then if I start with 2, then I'll get 6 factorial divided by 2 factorial into 2 factorial. Why? Why did I write 2 factorial now? Because I already exhausted 1, 2 here. So that will give you another number. Similarly, if I have 4 here, then it will be 6 factorial divided by 3 factorial into nothing. Because 1, 4 is already used. So that will give you a number. This number plus this number plus this number will give you the total number of possible values. Is that clear, guys?
Sir, I have a doubt.
Tell me.
Sir, in the first step only, why can't we write it as 3 factorial into 6 factorial upon 3 factorial?
Like what did you say? What did you want to write?
Sir, in the first step only, we can the first place can be filled with 1, 2, 4. So it's 3 times. So 3 into the remaining 6 places, like 6 factorial upon.
But you can't do. But you can't do 3 into. No, if you do 3 into, see, are these numbers the same? Because when you're, see, if you do the 3 into, what will happen is you're eliminating the possibility when 2 is coming in the first place, then the denominator becomes 2 factorial instead of 3 factorial. You're eliminating that process. No? You could have written 3
Understood,
into,
sir.
had all the numbers had equal probabilities. Then you could have used it. Okay, see, to answer your question precisely, had the question been like this 1, 1, 1, 2, 2, 2, 0, 0, 0, if everything had equal probability, then I could have done the 3 into something. Okay. So we'll do one last problem, guys. Remaining things I've already solved in my previous year's batch. I'll share those videos with you. You can try them out. Okay. If you have any doubt, you can reach out to me. In how many ways can 5 girls and 3 boys be seated in a row so that no 2 boys are together? You have 5 girls and 3 boys. You want them to be seated in a row so that no 2 boys are together. So first job is to separate them. So how will you do it?
So boys in odd positions.
So 1, 2, 3, 4, 5, 6, 7, 8. Right. You have 8 blank spaces. You first make the girls sit. So if girl sitting here, girl, let me try and see girl, 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 girl. But the 5th position is missing, right? So I need to ensure that girls are sitting in the even position. GG. Is this working now?
Yes,
1,
sir.
2, 3, 6, 7, 8. But one more girl is missing, no?
So that's what in the 9th place, I mean, sorry, the second last place, we write another girl.
Here, huh?
Yes, sir. Girls can sit together. That's not a condition. So
Yeah,
3
that's not a
boys
condition.
in.
So 3 boys should sit separately.
So we'll have to calculate for like 3 or 4 times like that.
Yeah, that's there. But I'm thinking if there is an easier way to do this problem. In how many ways can 5 girls and 3 boys be seated in a row so that no 2 boys are together? Okay. So how many ways can girls be arranged among themselves? So that is a condition first. So we need to solve that first. Girls can be arranged among themselves in 5 factorial ways. Right? When you do it in 5 factorial ways, how many blank spaces are left out? But I have a question here. The question is slightly ambiguous. In how many ways can 5 girls and 3 boys be seated in a row so that no boys are together? Does that mean that girl can sit anywhere? But does that mean that boys have only 3 blank spaces? 1, 2, 3, 4. So how many blank spaces are we going to give to boys is the question. Because they didn't say the row needs to be only of 8 numbers, right? Is that right? Are you able to understand what I'm asking? They didn't. That's what I'm thinking. They didn't mention that the number 2 in the row has
Sir, can
only 8. So 1, 2, 3, 4. Wait, let's try this and see. So first, let's make sure that all the girls are sitting separately. Girls, girls, right? So 1, 2, 3, 4, 5, 6. The boys can sit anywhere now. The girls' main objective is to separate them. But it doesn't mean like Subraj is like how you told, it doesn't mean that girls can sit together also. That is also another combination because that 5 factorial will include that also. Okay. So how many blank spaces do the boys have now? Spaces available for boys. That is 6. 1, 2, 3, 4. 5, 6. So in those 6 places, we need to arrange 3 boys. So 6p3 into the girls can be arranged among themselves in 5 factorial ways. So this would be the answer.
Sir, I have an idea.
Yeah, tell me.
Sir, they've mentioned 2 boys together. Like no 2 boys can sit together. So like the third boy can sit anywhere he wants. So the what I'm trying to say is so basically one girl should come in between both the boys.
That is the meaning. That is the meaning. Correct.
Sir, 1 second. Okay, no, let me think. Sir, but it need not mean that only one girl can come in between. It can also be like 2 girls are coming in between, right?
It can come, but in that 5 factorial, that 2 girls coming together will also get covered. You have to understand, because I didn't treat all the girls as one object. The girls can sit among themselves in 5 factorial ways. That is what I have written. In that 5 factorial thing, girls coming together is also covered. But what we are ensuring is, we are ensuring that boys only have 6 places available. We are first solving that condition into arranging the girls among themselves. That is the meaning of this. Okay, think about it. Okay. So remaining, how many problems are there in miscellaneous?
Sir, I think I got.
Yeah, tell me.
Sir, so as you arranged, like one girl should come in between. So 2 boys, say in the first position, first boy, and in the second position, second boy. So like that, 3 like like that. So the rest of the members are 3. So 5 members are left if we take 3 members in the starting, including one girl in between. So the 5 members can be arranged in 5 factorial. Like one boy can come in between over there, anywhere, and then this can be arranged in well, 2 ways, I believe, because boy 1 and boy 2 like that.
No. See, thing is, no 2 boys are together, but that is what my question is. They were to be seated in a row, but they didn't say that row should contain only 8 members. So one boy can sit here. This place might be empty. The other boy can sit here. This place might be empty. The other boy can sit here. Why are we restricting saying so? In that case,
sir, that is only my condition. Like I haven't finished.
Yeah.
Sir, so after like first we calculate like boy, girl, boy, and then like rest of the members is 5 factorial. And then again, second condition or so it will become plus. So a plus, and then again it's the same thing only, like 5 factorial, 2 into 5 factorial. So basically,
but don't
5 times 2 into 5 factorial.
Listen, don't bring a plus here, because you're not creating an OR condition. You're not ready to create an OR condition because you have not made the boys sit there. So unless you complete that 5 factorial into something, you're not supposed to go for the OR condition. Try to understand, think about it. So both should happen simultaneously. You need to solve that problem first and then go to the next. Okay. If possible, you solve it and send it to me. No? On a paper, solve it and record it and send it to me. Whatever you have in your mind, I'll validate it. Okay. So the other problems, 11 problems that are there, that I've already solved it, and I'll share that video with you guys. Okay. You guys can try it. If there is any doubt, you can refer the video. In spite of it, you have any doubt, no, you can reach out to me on the student support number. So can I assume that this chapter is clear? So only thing that is left out is probability, right? Yes or no, guys? So only thing that is left out is probability. Maybe we'll discuss it tomorrow. That is a very small chapter, nothing to worry. You are already good with this, no? That is even more easier. So We'll do it tomorrow. Okay, I'll see you all. So maximum 2 more classes, guys, to be done. So tomorrow's class will also be at this time only. And maybe if possible, I'll try to take on Thursday or something and close it off. Don't worry. Okay.
Thank you, sir.
Yeah.